Now, welcome to this reference-packed lecture. As a C# developer, switching to Python can feel unfamiliar, but it doesn't have to be. In this lecture, we'll walk through a compact C# versus Python syntax cheat sheet that maps what you already know in C# to its Python equivalent. Now, let's start with the syntax basics. In C#, we wrap code blocks with curly braces and end statements with semicolons. Okay, like this. And we are wrapping this else statement or even the return statement with curly braces. In Python, there are no braces or semicolon. There are no semicolons. Okay, no braces like such. This one is different. This is for F string. This is a special case where you are still using the curly braces, but for all practical purposes, you are getting rid of the curly brace. Okay. Now, in Python, there are no braces or semicolons, indentations and colons. So, you do the heavy lifting by indentations and colons. Python reads more like pseudocode, which makes it incredibly readable once you get used to the format. So here is a list of int x equals 5, Python syntax equivalent is this, then print statement here and console.writeLine in C#, and it's the if statement. Here it is like this, return true if x equals 0, else false. Okay. And for statement, this is the for statement equivalent in Python syntax, and list and dictionary in both the languages. Okay. Now, control structures. Control flows in Python like if, for, and while. If, for, and while. Now, they map clearly or cleanly to C#, but with simpler syntax. So, no parentheses required around conditions. No parentheses required around conditions. There is no parenthesis, and blocks are defined by indentation. The elif keyword in Python replaces else if in C#. Let's see functions and methods. Defining function in Python uses def keyword, as you are now aware. There is no need to specify return types or access modifier. Okay. So Python functions are inherently public and dynamic. If you are used to void in C#, just remember that a Python function without a return simply returns none. Here it returns a plus b, but if there is no return statement, it doesn't return anything. So there is no void, unlike here in C#. Okay. And then let's see collections. In Python, we work with lists, tuples, sets, and ticks. So this is my set, this is a list, and this is tuple, dictionary. Lists are the closest match to listy in C#. List of int is a list in C#. And dictionaries are similar to dictionary T key and T value. This is a type key and type value. Dictionary string and integer. And tick is the nearest to this dictionary. Indexing is zero based in both languages, but Python's slice syntax is powerful and compact. So I just said that Python slice syntax is powerful and compact. So what is a Python slice syntax? Let's revise it. I mean, I have done it in one of the lectures previously, but let's do it again. So Python slice, what is a slice syntax? The sequence is start, stop, and step. So where start is the index to start at, which is inclusive, and stop is the index to stop at, which is exclusive, and step is how many items to skip, optional. This step is optional. So why it's powerful? No need for loops. Nums is a list. This is Pythonic list, which has these elements 10, 20, 30, 40, 50. And if you print nums 1 to 4, it will print out 20, 30, 40. And how? And why? Because it starts at index 0. The first index is 20. Okay. And it goes to the index 4, which is 50. But the last index is exclusive. Okay. It is exclusive. So it will print out 20, 30, 40. And it supports reverse and skipping. So nums, when you write like that, in start and stop are not specified. And the start, stop, and step -1. So if it is -1 step, then it starts from the reverse. So it starts from 50, then it skips one step, 40, then 30, then 20, then 10. Now it comes up to the first index or the 0th index because it actually because it is because stop equals none. Okay, slicing feels inclusive, although it is exclusive. So index to start as is inclusive, and index to stop at it is exclusive. It should include the start index and it should exclude the stop index. But sometimes there is an exception because it looks like that stop index is exclusive, but in this case, it is even though it is exclusive, it feels inclusive because stop equals none. And here it ends at the last valid index due to stepping. So how it will be, this is start is not specified. So it is the first taken as the first element or the 0th index element, and this is it is none, and the step is 2. So it starts from 10, jumps by 2, skips the in between. So 10, 30, and 50. So it feels inclusive, although it is exclusive still. It always holds good. Okay. So let's run this example just as an exception. As I previously told that we are not going to run it on Visual Studio Code because there is hardly any coding to walk through, and I will quickly run this. So when I run this Python slice.py file, this is for slice examples. The nums is again the list of numbers 10, 20, 30, 40, 50, and then a number of printf statements, which I am going to quickly run through as an explanation. So when I run this, the first statement that I get is slice nums 1 to 4. 1 is the start, this is the stop, and there is no step here. So it gives you the answer 20, 30, 40, and original is this nums list. Okay, so this is clearly understood, I hope. 1 to 4 means the first number is the 1th index, that is 20, and then 4 is 50, but 50 is excluded, so 20, 30, 40, and step of 1. Okay, and then the second one is again 20, 30, 40, print nums 1 is to 4, and then print nums colon colon minus 1. So it is reverse, it starts from reverse. If it is step is -1, then it starts from the opposite order. It starts from 50 and it reduces by 10. The next one is 40, and then 30, 20, 10. It doesn't skip. Okay, and similarly, it starts with this is not specified. Starts is not specified. Stop is none, and the step of 2. So it starts with then 10, 30, and 50. By jumping one step in between. And this one is 20 and 40 because the starting point is 1 at this index 20, and then in step of 2, that is 40. That's it. And this is at index 4, which is 50, which is exclusive, which is not included. So it is only 20 and 40. And similarly, this one, it shows in Python, it demonstrates that there is no index out of bound exception, and it also starts from 2, that is 30, and in step of 1, because step is not specified, end is 10. So the 10th index is not there. So it was supposed to have crashed in C#, but it doesn't crash. So it straight away goes to 30, 40, and 50 because there is a step of 1. So 30, after that 40, then 50. So all the elements after 30 inclusive are covered. Okay, this I have already covered. So works on strings distant to tuples. If name is a string, Python, print name from start is P because it is not specified, and this is up to start, stop, and step. So stop is at 3, PYT. It prints out PYT. Okay, and no index out of the bound errors because which I have just told, it doesn't crash. Now here again, if you have a closer look, by PYT, it starts from the index 0, that is the first place, and then second, and then third. And this is actually index 3, that should be H, but H is exclusive, so H is not printed. So only PYT are printed. And why it is compact? C# equivalent is more verbose, like variable numbers is new list of integer 10, 20, 30, 40, 50, and result is nums dot get range 1 to 3. And in Python version is simple and elegant, nums just 1 to 4. Okay, so start is 1, stop it at 4. So this is inclusive, this element is exclusive, and is simple and elegant. How Python interprets steps in slicing, that's also I have told. Print nums 1 to 4, interpreted at starting point is 20 because this is 1 at index 1, and stop is 4, exclusive, and step 1 is default. So it starts at 20, 20, 30, step is 1, then 40, and then 50 is exclusive. So this is not printed out. So 20, 30, 40. All right. And what if you add a step? Nums 1, 4, 2, starting point is 20, 1 at 20, stop is 4, step is to 20 and 40. Default step is 1 unless specified. Negative step means reverse direction. Right. And then error handling. Error handling in C# and Python are quite similar, except in here it is try catch exception, and here it is try and accept exception as E. And this is no catch, it is except. And then of course, finally. And instead of throw new, we raise exception with the raise, raise exception error. Here it is throw new exception error. Okay. Python also encourages checking for none and raising exceptions explicitly, which matches the intent of throwing if null in C#. So if argument is none here, so it raises value error, argument is none. There is some object-oriented syntax. Python is also object-oriented, but lighter on ceremony. There are no public private keywords by default. The constructor is always named underscore init underscore. This is actually, I have already taken double underscore. Dunder, init, dunder, and self must be the first argument in all instance methods. So self.h, properties are just variables prefixed with self. This is a public property in C#, where it is in Python written as self.age. Okay. Now the LINQ versus Python comprehensions. So you might love LINQ in C# and Python has something equally elegant, list comprehensions, which we have already learned actually in this loop section. A single line x into 2 for x in nums if x is greater than 0 replaces both filtering and projection and is used everywhere in Python data science. So C# equivalent syntax is nums dot, where x goes to x greater than 0, dots after going through this condition selects x into 2, multiplies x multiplies by 2. Okay, and it is much shortcut, easy to remember and implement. So in Python. Okay, so finally we come to namespaces and imports. While C# uses using to import namespaces, Python uses import. So import math, and then from math import square root. You can also import specific functions or classes using from module import name, giving you more flexibility. Python imports are lighter and easier to manage, especially in notebooks.